Hello everyone, I made this video in response to a question posted on Facebook groups. The question is shown on the screen. I was thinking that other people might find the solution useful as well, together with the explanation. If you like such videos, please subscribe so that you will be notified when I post answers to other people's questions. In part A, we want to find the gradient of the line L2. So L2 has the equation 3x plus 2y minus 8 equals to 0, which I have copied down in the space below. Our aim is to convert this equation into the form on the right in the yellow box that I have shown, y equals to mx plus c. In this form, the m would be equals to the gradient of the line. Then if we have the equation in this form, it will be very easy to identify what m is and therefore the gradient. So the first thing I do is to keep y on one side and move all the others to the right hand side. So I will get 2y equals to negative 3x plus 8. Then I will divide throughout by 2 and I will get y equals to negative 3 out of 2x plus 4. And if we match it with the yellow box on the right, you will notice that the gradient is negative 3 out of 2 or negative 1.5. You can also write negative 1.5, but it's better to leave your answers in fractions because they are more exact. For part B, it is given by the question that the intersection of line L1 and line L2 is P. So the intersection is at point P. And we are asked to find the coordinates of P. So what we need to do is to solve simultaneous equations. So there are two ways we can do it. Is to solve the equations of L1 and L2 simultaneously. So on the left you see a pair of equation. For L1 we have y equals to 3x plus 2 from the question, and L2 is 3x plus 2y minus 8 equals to 0 directly from the question. Another way you might want to solve the simultaneous equation is using the pair on the right, and that is to use the modified form of L2 from our previous part. So you will use L1 y equals to 3x plus 2 and L2 y equals to negative 3 out of 2x plus 4. I'll show you each of them separately. So method 1, using the first pair, it's a method called substitution. We first label our equations 1 and 2 very clearly. This will help us in our presentation of our working. So let's give ourselves some space. What we want to do is to substitute y into whenever we see y. So y equals to 3x plus 2. So when we see y in equation 2, we want to replace the y with 3x plus 2. So we need to tell our reader what we are doing. So please write the statement, substitute equation 1 into equation 2 like shown on the screen. And here I've gone to substitute 3x plus 2 in place of y. So we will get 3x plus 2 times of 3x plus 2 minus 8 equals to 0. Now I'm going to expand the bracket. So instead of 2 times of 3x plus 2 in pink, in the next line we will have 3x plus 6x plus 4 minus 8 equals to 0. And then I will proceed to solve for x. We have 9x minus 4 equals to 0. Then 9x equals to 4. And so x equals to 4 out of 9. Now we are not done. We'll need to find the value for y. So I'm going to substitute it back into equation 1 and replace x with our value 4 out of 9. So on the right you see that I have written equation 1 gives us when x equals to 4 out of 9, and before I proceed to write more working. Right, so now I will replace or substitute the value of x, which is 4 out of 9, whenever I see x in equation 1. So we will get y equals to 3 times of 4 out of 9 plus 2, and that will eventually give us 10 out of 3 or 3 and a third in mixed number. So we have gotten the values for x and y. And remember to give the coordinates of P in coordinates form because the question asks us for the coordinates, not x and y value. Right. The second method that we might want to use is both equation of L1 and L2 in this form shown on the screen, where both have y being the subject on the left hand side. In this case, we can equate both equations. So instead of the previous method, if I start from this, I can equate equation 1 with equation 2. The first thing I should write would be equation 1 equals to equation 2. Then I'll proceed to show equation 1, which is 3x plus 2, will be equals to equation 2, which is negative 3 out of 2x plus 4. Then I'll go ahead and manipulate the terms and moving all the x's to the left and all the numbers to the right. I will get 3x plus 3 out of 2x is equals to 4 minus 2. And then 9 out of 2 or 4.5x is 2. Then eventually, by dividing by 9 out of 2 or multiplying 2 out of 9, I will get x is 2 times of 2 out of 9, which is equals to 4 out of 9, which is the same as what we got previously with the other method. Now again, we haven't solved for y, so we can do exactly the same thing by substituting the value of x into equation 1 as per previously. Or you can also choose equation 2. I will choose equation 1 because it's easier without the fractions. So just like what we did before, we will substitute the value of x, which is 4 out of 9, into equation 1, 3x plus 2, and we will get y equals to 3 and 1/3, and remembering to give our p in coordinate form. So for part C, we are given new information. It says that the lines L1 and L2 crosses the line y equals to 1 at the points A and B respectively. Now the line given y equals to 1, that is a horizontal line, cutting the y-axis at 1. So now we are asked to find the area of the triangle ABP. So it might help if you can visualize with a diagram. Otherwise, it might be a bit difficult to imagine what you're calculating. So first, let us recall what we have from the previous parts. We have line 1, y equals to 3x plus 2, which we used to call it equation 1, and the manipulated form of L2, which we call equation 2 in our second method. So y equals to negative 3 out of 2x plus 4. We also use them to find the intersection of these two lines at P. X coordinate is 4 out of 9 and y coordinate is 3 and 1/3. So right, so now we can try to draw a sketch if you can, or if you can draw it quite accurately, that would be the best, but don't let it bother you too much. So for line 1, it has a positive gradient of 3 and a y-intercept of 2. So with a positive gradient, it will be a straight line sloping upwards, like shown on the right with the straight line in yellow. So with the same concept, line 2 has a gradient that is negative 3 out of 2. So, and it has a y-intercept of 4, so it will slope downwards. Now the intercepts is just extra information. It would be good if you can directly plot straight lines using this in the form y equals mx plus c. Don't let it bother you too much. What is most important is the direction of the line, whether it slopes up or down according to the positive or negative gradient. Also take note that these two lines, the yellow line and the green line, will intersect each other at the point P, which we have found earlier. Now we want to also pay attention to the line given y equals to 1, which is shown in the diagram in red. So I try to color code it for easier reference. So thank you to the other teacher on the same Facebook group who provided this diagram. Like I say, if you could draw straight line quite accurately, that would be the best. Otherwise, you just need to know the direction, whether it's positive or negative gradient, and you should be able to draw two straight lines that intersect at P and a horizontal line y equals to 1. So now let us transfer the coordinates onto the diagram for easier reference. And since the red line is a horizontal line, and we see that the triangle is enclosed by the three lines, the yellow, the green, and the red, we can use the simple formula of area of triangle, that is half times base times height, to find the area. In order to do that, we will make use of the coordinates of the 3 points of the vertex. So what I want to do is to substitute y equals to 1 into each equation. So for the first one, when y equals to 1, I will substitute into y equals to 3x plus 2 on the top left. So I will get 1 equals to 3x plus 2. And then I will proceed to manipulate the equation. So 1 minus 2 equals to 3x, and negative 1 is 3x, so negative 1/3 is x, so I will put x on the left, so x is negative 1/3. Now I will know that a, which is the coordinate on the left, is negative 1/3 and 1. I do not need to recalculate y because it is given. In a similar way, I will substitute y equals to 1 into the second equation to find the coordinate of b. So 1 equals to negative 3 over 2x plus 4. After I manipulate, I will get 3 out of 2x is 4 minus 1. So 3 out of 2x is 3. And then x would be equals to 2. So the coordinate of b is 2, 1. If your diagram is quite accurate, you should be able to see that your answer is correct. Otherwise, you should at least get an idea of whether a is positive or negative. That should help you quite a bit. Same thing, I will transfer the coordinates onto my diagram so that it's easier for me to figure out the base of the triangle as well as the height later on. So now back to our formula. Area of triangle is half times base times height. I've indicated on the diagram the blue part being the base, which is the distance between the points A and B, and the height should be perpendicular to the base as shown in purple, and it should be a vertical line going from the blue line upwards to P, and we will use the coordinates of P to help us find the height. So to find the height, we use the y coordinate of the P, which is 3 and 1/3, subtract by the red line, which is y equals to 1, to find the distance, the purple distance, and we will get 2 and 1/3. For the base, we will find the distance between the points A and B, so I will take the x coordinate of B, subtract the x coordinate of A. So 2 subtract negative 1/3, so I actually have to add 1/3, so I'll get also 2 and 1/3. It's a coincidence. So now I can substitute my values into area of triangle equals to half times base times height. That will give me half times of 2 and 1/3 times 2 and 1/3. So if I were to use a calculator, I could punch all these numbers in. Otherwise, it might be easier to work with improper fraction like I have done. So half times 7 out of 3 times 7 out of 3, I will get 49 out of 18, or 2 and 13 out of 18 units squared. So that's all for this question.